This is Chapter 6, Section 3, Problem 31. Translate the statement into a confidence interval. Approximate the level of confidence. In a survey of 600 adults in the country, 82% think teaching is one of the most important jobs in the country today. The survey's margin of error is plus or minus 4%. A confidence interval. For the population, proportion is p hat minus the margin of error is less than p is less than p hat plus the minus of error, where p hat is the sample margin of error and e is the well, p hat is the sample proportion and e is the margin of error. Determine the sample proportion p hat and s, the point estimate of the proportion of adults who think teaching is one of the most important jobs in the country today by converting 82% to a decimal, which would be 0.82. We find q hat by subtracting 1 minus p hat, which gives us our q hat here, okay, which is 0.18. Calculate the value of e, the margin of error, by converting 4% to a decimal, which is 0.04 here. So we found the left end of the confidence interval by subtracting the margin of error from the sample proportion there. So we have 0.82 minus 0.04. You find the right endpoint by adding the margin of error. We end up with 0.86 here. So the confidence interval here is going to be from 0.78 to 0.86. Then they ask us to verify the sample distribution for p hat can be approximated by the normal distribution, affirming that n times p and n times q are both greater than or equal to 5. So we multiply here. We have n times p hat, which gives us 600 times 0.82, 492, that's more than 5. And we have n times q hat, which is 600 times 0.18, that's more than 5. So since n times p hat and n times q hat are both greater than 5, the sample distribution can be approximated by the normal distribution. So it has the properties of a normal distribution here. Okay. So approximate the level of confidence. Note the formula here for the margin of error is given to us here, where n is the sample size and z sub c is the critical value from the standard normal distribution. Okay. So to find the number of level of confidence, use this formula here and find underneath the curve for z hat, for minus z sub c and z sub c here. So these correspond to probabilities here on each end. So we can solve for z sub c here, which gives us a z-score corresponding to that, the critical value for the normal distribution. So we solve for z sub c. And they plug in for our e. We have our p and our q, and we have our n. So the z-score coming from that is 2.55. Okay. So for the level of confidence C for the interval, uh, 0.78 to 0.86 is equal to the area under the curve between negative z sub c and z sub c. technology or distribution table to find the area. So we have our negative here and our positive. And area to the left is there, 0.054, and to the right is 0.99456. So the area is going to be the difference between them, which comes out to be 0.9892. So therefore, this interval has approximately a 98.9% confidence interval.